In this video, we are going to be talking about differentiating from first principles. Let's do a quick do now problem. Given that f of x is equal to x squared plus 1, find f of x plus h. For all of the input value of x, the return value is x squared plus 1. So instead of putting x, we're interested in finding what would happen if it was x plus h. For all the values of x, you're going to change the value to x plus h. Therefore, we'll get the quantity squared plus 1. We can simplify this by foiling it. We get x squared plus 2xh plus h squared plus 1. Now let's do a quick review from Sal's video. Given that y is equal to f of x, we learned last time for all the inputs of x, you would get an output of f of x. If I'm increasing the x by h, then the input now will be x plus h, and then the output will be f of x plus h. In order to find a gradient, we would need to do m is equal to y1 minus y2 all over x1 minus x2. In other words, we're going to have the difference between the y values on the numerator and the difference between the x values on the denominator. It turns out we get f of x plus h minus f of x all over x plus h minus x. However, we can cancel out the x's, and therefore we're left with f of x plus h minus f of x all over h. So then let's talk about as a point B approaches A, gradient of a line approaches a gradient of a tangent line. In other words, as the distance between the x and x plus h gets really, really close together, we're left with this equation. This gives the gradient of the tangent to the curve y equals f of x at the point x and f of x. Since every value of x has at most one gradient, this will be a function. We say this is differentiating from first principles. So let's use the definition of f prime of x to find the gradient function of f of x equals to x squared. In order to do so, we need to use what we have just boxed, this one. So we already have f of x, which represents this value over here. All we need is f of x plus h. Very similar to the problem that we did in the very beginning. So if you have f of x plus h, this function, every x you're going to replace the value with x plus h. Therefore, it'll become x plus h quantity squared, which we can simplify it as x squared plus 2xh plus h squared. So we're almost there. Let's find the derivative of a function, which as limit h goes to 0, f of x plus h, right here, this is what we just found. So we're going to write x squared plus 2xh plus h squared minus, right, f of x, which is just x squared. And then we're going to put it all over h. Nice thing about this equation is that most of the times, many things will cancel out. In this case, my x squares are going to cancel out, and I'm going to be left with limit as h goes to 0. 2xh plus h squared, which they have both h's in common, so I can pull that out. 2x plus h all over h. And from the previous chapter, we learned that we can cancel out these two things. Therefore, I'm just left with 2x plus h. And we're going to plug in the value of h equal to 0, and you're left with 2x. So what does 2x mean? It means slope at any given point on this function. On any given point on x, on f of x equals to x squared, the slope could be represented as a 2x. Let's move on to the next slide. So in SL book, you'll find it, they're using many different vocabularies for one thing, but it all means the same thing. The y prime, f prime of x, gradient of a tangent line, dy over dx, which means the change in y over change in x. Find the derivative of f of x. Differentiate f of x. It all means the same thing. It just means find the slope of a function. So in the following example where it says to find the instantaneous rate of change in f of x equals to x squared plus 2x. Well, by now you would be an expert at finding a slope. At any given point, we are going to use the first principle rule, which is f prime of x is equal to limit as h goes to 0, f of x plus h minus f of x, all divided by h. Here we already know what f of x is. F of x is this guy, which is going to represent the second part of the numerator. And I'm going to do a direct substitution this time. So here we have limit as h goes to 0. F of x plus h is sort of like replacing all of your x values with x plus h, right? So I have x in here and another x in over there. So I'll have x plus h, quantity squared, plus 2x. You're going to replace that with x plus h. And then here you need to be careful because we have minus f of x. Minus f of x, which is again x squared plus 2x. All over h. Let's go back to the black color. So here, let's FOIL a couple things and try to cancel it out. So if we FOIL the first one, we get x squared plus 2xh plus h squared plus 2x plus 2h minus x squared minus 2x. See what I mean by be careful this negative number? We have this negative f of x, so if we totally ignore that, I wouldn't get negative 2x at the end. I would have positive 2x, which will complicate many things. So all over h. Let's try to cancel things out in here. X squared, negative 2x, positive 2x. You're always gonna left with like the h's in common over here. So you can pull out the h. Limit as h goes to 0. You have 2x plus h plus 2 all over h, of course, divided by h. And then we have cancel out the h's. We're left with 2x plus h plus 2. But really, we're going to plug in the h equal to 0. So we're going to be left with 2x plus 2. So that 2x plus 2 represents the slope at any given point. Here, that given point is x equal to 5. So let's see the question one more time. Find the instantaneous rate of change in this function at x equal to 5. So when derivative of a function at 5 would be just plug in this 5 onto the new equation that we found, the slope equation, 5 plus 2, that's 2 times 5 is 10, plus 2, 12. So 12 would be the gradient at 5 on this function.